So you went to the toy store like Harbor Freight and bought yourself a new incandescent test light. Let me show you guys how to bench test it to know exactly how much current it's gonna draw. And then two, let me show you guys how to modify the end to add a stackable end. So this way you can use your test light with back probe, an alligator clip, a Pierce probe, or any other probe that we have available for our scopes or any other use. Stay tuned. Let's set this bad boy up. All right, so let's take this bad boy out of the package. So it just comes with an instruction manual. You guys know how we roll, because we're gonna figure it out the hard way. All right, so what I'm gonna do, this is my power supply. Again, this one we got on Amazon. We're gonna go ahead and set the voltage to 12.6 so we can simulate a fully charged battery. So we're gonna do 12.61 volt. So from there, I'm gonna go ahead and take my ground lead and put that right there. And I'm going to take my power lead. So I'll remove this cover here and we'll go straight there. So you guys can see we're drawing 221 milliamps at 12.6 volts. This right here is letting me know what this test light is going to draw based off of a 12.6 volt circuit. Now, before you guys start jumping into the comment section, I went ahead and raised the voltage up to 13.5. We're still at 228 milliamps. And we can always increase it a little bit more. Let's go to 14.5. That's still putting us at 240 milliamps. All right, so now we have that information down. Go ahead and turn on our brother labeler here, and we are going to set it at 221 milliamps. We'll hit print. And there it is. And there we go. So now we got our label on it. So anytime I want to use this to substitute a load, I know it's going to draw around 221 milliamps at 12.6 volts. So this way, when I want to substitute this as a load, I have that information ready to rock and roll. And again, if we went up to like 14.5, we were only 228. So it was only 7 milliamps more. So again, you know, we're not going to use this to substitute a load or a circuit that's 100 milliamps. We're not going to do that. Okay, so this is just for me to know how much this draws. So this way, when I substitute, I know that I'm not going to be killing a circuit. Now let's go ahead and prep so that we can remove this connector and go with our double stack connector like this. And this way you guys could see the entire process. Let's get it going. All right, for some reason, I always like to leave a little piece of wire just in case I screw this up and then I need to redo it. So I'm going to take my straight cuts here and I'm going to cut this off right there. Right, and then now we have a workable wire to be able to get this going. All right, so what I ended up having to do is I underestimated the thickness of the actual insulation for this wire. So I had to trim some of it back using my pocket knife. What I am going to be doing is I'm adding a piece of heat shrink and bringing that back over here. So then this way, once I put this together and solder it, then I'll drop the heat shrink down and then heat it back up. So then this way we have a sealed proof double stack connector. This goes like that. This solders into this, and then this cap goes over it just like that. If you guys are doing the same exact project with this style, just remember it's a little bit thicker than what we have available here. So you just gotta work with what you got, right? Okay, so that's what I did now. So let me go ahead and set up my soldering blocks. So this way we can solder it up and then put it all back together. So as always, guys, before you guys start soldering, make sure that you guys pre-tin your soldering iron, clean and ready to go. And flux, flux, flux. Make sure you guys are using a lot of flux, so this way you can get some good solder joints. Flux makes this whole process go that much easier. All right, so once you're all said and done, you'll go ahead and push this back in to your carrier there. Put your cap over it. And that's all done. Now I'm going to take my heat shrink and bring that over just a wee bit there. I'm going to turn on my rework station to blow some hot air. We'll give it another round. All right, you guys can see that I got it in there now. So let's go ahead and heat this whole thing up. So now with the end that I installed, I can add stuff like an alligator clip. And then if this goes to ground, I can connect another ground right here. So now it's connected to our power supply so we can see it in action. So because my power supply has 1/4 inch jacks, I could go straight to my power supply on the ground, and then now just go here to the power, and what do we got? It's working just like we intended a little bit ago. So the benefit of doing this again, guys, is just one, we want to make sure we know what the load is of the actual test light, and two, using an end like this, then this makes it super universal on anything we want to use, instead of just the standard one that comes with the unit that has to be clamped on. Now I can use alligator clips, I can use a back probe, I can even use a pierce probe on this, all because I changed the end on my actual test light. All right, so I'm bound to get somebody to say, that's gonna say, I don't have a power supply like you do. What am I supposed to do now? Okay, pretty sure you have one of these. If you have a voltmeter laying around, you can do the same simulation. Instead of using a power supply, you use a battery. So let me set up my voltmeter so you guys can see how you would do it if you don't have a power supply, but you have a battery that has 12.6 volts. Let me show you guys. All right, guys, so if you don't have a fancy power supply, you can always use a battery. So I'm gonna simulate my power supply as a battery. What you're gonna do is you're gonna take your test light and you're gonna plug it into the ground of the battery, just like a standard ground connection. Then what I did is I took my positive side of the battery into my meter, and then I'm going to take my common and connect it to my test light. Now when my light turns on, notice how on my meter I'm getting 220 milliamps, so just like what we're reading over here on the power supply. So then at that point, just go ahead and make your sticker and then go ahead and place it onto your test light, and now you have an accurate reading of how much current this device is going to be pulling. So again, guys, anytime you guys get a new tool such as incandescent bulb, a sealed beam bulb like the one I showed prior, an incandescent test light like the one you just saw, maybe even an LED test light, always make sure you guys load test it, know exactly how much it's going to be pulling. This way, whenever you need to use it, you already know what that tool requires. So this way, if you substitute it for a load, or even if you introduce it to a circuit, you know exactly how much that tool is going to draw current wise. If you guys made it this far, I really appreciate it. Go ahead and give us a like, a follow, share this video so we can continue our mission of bettering the automotive industry one technician at a time. This starts with you guys. Thank you so much for the support. I hope this information was super useful. Numbers don't lie. According to YouTube, about 80% of you guys watch these videos but don't like or subscribe. Do me a huge favor, let me know in the comments if you guys ran this and how simple was it for you guys to actually do these modifications, and also test your test light to see how much current it was actually drawing. Make sure you guys check out the description. There's going to be a couple links, some to our online classes and also to our student store where you guys can pick up some cool tools, some new merch, so you guys can help support the school and our students that are attending classes. This is Oscar Gomez from Master Automotive Training. I'll see you guys on the next one.